Good morning, dear students. So today we'll be conducting a revision of DFS 6 textbook because in the last class we have completed the chapters. So this today we'll complete a revision of the whole book. I hope you're all safe and sound, keeping good health, and this must be the last YouTube live streaming class. And Monday onwards, there won't be YouTube live streaming class. We'll be uploading videos and classes in the channel, so you can go through those uploaded classes, and all the classes which are taken so far is available in the channel. So we will go chapter by chapter, starting from the first chapter to the last chapter. Any specific doubts, either you can type it through live chat or ask your concerned faculties. Okay, so we'll go to the first unit, which is physics and chemistry of combustion. So in this, we have discussed about the definition of fire initially, because as a fire and safety professional, when you go for interviews, etc., one of the common question which is asked to a fire and safety professional is what is fire or what is safety. So fire is a chemical reaction. And what is reacting? Of fuel in the presence of oxygen at a requisite temperature. So the three elements, fuel, heat and oxygen, and producing heat and light. So the definition of fire is a chemical reaction of fuel in the presence of oxygen at a requisite temperature, producing heat and light. And further, we discussed about what is happening in this chemical reaction. So for that, we have gone into the structure of elements, how substances are made, what is the smallest particles like molecule, atom, and what is the structure of an atom. So all this we discussed mainly to study about the chemical reaction happening in a fuel, sorry, in a fire. So you can go through that part. So what is an element, what is a compound, what is a mixture? The elements are those substances which have same type of atoms in the molecule. Compounds are those substances which have got the same type of molecules throughout the matter. Whereas when you have a different type of molecules, we call it a mixture. And what is chain reaction? That is what we learnt. That is the free radicals formed in the reaction of fuel with oxygen, absorbs and releases energy. And it is this energy which comes out as heat from the fire, which keeps the fire burning. So the chemistry is the release of free radicals, which releases energy as heat and light, further evaporates the fuel and keeps the fire burning. So the fourth element of fire was the chemical reaction of fire. So we learned about the exothermic chemical reaction, how it is happening. So after that, we came into the physical aspects of fire. See, when we learn about the physical aspect of fuel, first its state, whether it is solid, liquid, or gas, then the density of the fuel, which is mass by volume, then heat as an energy, it is measured in joules, and 1000 joules is 1 kilojoules. Apart from kilojoules, it can be measured in calorie in SI system and British thermal unit in FPS system. And 1 calorie is approximately the heat required to raise the temperature of 1 gram of water through 1 degree centigrade. And 1 British thermal unit is the heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. After that, we learned about the measurement of heat. See, the heat is measured as an energy in joules, but as far as we are concerned, when we say something is hot, we generally refer to the temperature, which is the degree of hotness of a body. And that degree of hotness is measured as temperature in various scales like degree Celsius, degree Fahrenheit in FPS system, and absolute scale, which is Kelvin for scientific calculations. So we learned how to convert the temperature from each scale to the other scale. Formulas are given there. To obtain a Fahrenheit scale, when you know a centigrade scale, is to multiply the centigrade scale into 9 by 5 and add 32. And to obtain a centigrade scale, the Fahrenheit scale is to be subtracted with 32 and multiplied by 5 by 9. And to get the absolute scale, the centigrade scale is added with 273. So that is the various methods of converting temperature into various scales. After that, we learned about heat capacity, latent heat of evaporation, etc. And we discussed mainly about water, how much heat is absorbed by water. And we came to know that the maximum absorption of heat by water is in the boiling stage. That is when it changes its states from liquid to vapor. So at constant temperature of 100 degrees, at boiling point of water, it absorbs around 22 lakhs 60,000 joules per kilogram of water, which is referred as the latent heat of evaporization of water. So this has got a great importance when firefighting is concerned with water, because to know approximately how much heat is absorbed by water. After that, in that chapter, we learned about the expansion of solids, liquids, and gases. That is the effect of heat on solids, liquids, and gases, where we discussed about the latent heat of, sorry, the coefficient of linear expansion. We also discussed about the volumetric expansion of a liquid, and various gas laws like Charles law, Boyle's law, etc. And few important definitions we learned in that chapter. They are flash point, fire point, spontaneous ignition temperature or auto ignition temperature, and flammability range. These four things are very important as far as fire is concerned. Not only as definition. If you know this, it is very easy to understand how fire extinguishes. So flash point is the lowest temperature at which the liquid produces enough vapors for a momentary flash. All fuel have a flash point. Whereas fire point is the lowest temperature at which the liquid produces sufficient vapors for a continuous combustion. And spontaneous ignition temperature is the lowest temperature at which the vapor burns without ignition. And flammability range or limits of flammability or explosive limit of a fuel is the minimum percentage of, or you can say the percentage of fuel vapor in air to support combustion. The minimum percentage of fuel vapor to support combustion in air when it is taken as a 100% air fuel mixture is called lower explosive limit, and the maximum fuel vapor in air when it is taken as a 100% air fuel mixture, it is called upper flammability limit, and the fuel burns in between these range. And the theories like triangle theory and tetrahedron theory. As per the triangle theory, the basic requirements for a fire is fuel, heat, and oxygen. And as per the tetrahedron theory, for a continuous combustion, you need to have fuel, heat, and oxygen, and a chain reaction process happening. And the amount of oxygen required, etc., is minimum 14%, and amount of heat depends upon the flash point of the fuel, and the fuel has to be in the flammability range. Further, we have learned about liquefaction of gases, critical temperature, critical pressure, etc. Critical pressure is the pressure required to liquefy a gas below its critical temperature. Now, the last thing we learned in that chapter was about transfer of heat, because the fire spreads mainly due to heat transfer. The heat transfers in three modes. One is conduction, mainly happening in solids; convection, which mainly happens in liquids and gases; and radiation, where heat transferred without an intervening media. Mainly during a fire, the maximum heat transfer takes place due to radiation. So this is what we learned in the first chapter of that book. And as far as fire is concerned, this chapter is very important. If you know these terms and understand these terms well, you can learn about fire easily, especially when you come to the next book. And a lot of questions can be asked in interviews from these chapter like flash point, fire point, triangle theory, flammability range. So the second chapter we have learned about classification of fire and extinguishing media and methods of fire extinguishment. So in that we have learned about four methods of extinguishing fire. One is your cooling, where you limit the heat and extinguish fire. So normally when you extinguish fire by water, we adopt the method called cooling. The second method we learned was smoothing, where the fire is extinguished by reducing the oxygen content in the air to below 14%. The third method was starvation, where the fuel is limited to extinguish a fire. When there is no fuel, the fire extinguishes. And the last method was inhibition, where the chain reaction process is broken down. So the further heat does not comes out of the fire and the fire extinguishes. So the four methods which we learned there. And we learned about various extinguishing medias. The main extinguishing media we learned was water. So water can be used as an extinguishing media in three ways: as water jet, water spray, and converting water into foam. And the main method adopted by water is cooling, whereas it can also smother a fire due to the steam produced. Then, apart from water, we learned about carbon dioxide, which is considered as a clean media and can be used for fires where live electricity is involved. We learned about various vaporizing liquids, so we call it as clean agents, which turns into heavy vapor at a very low temperature. The olden medias like BCF, bromochloro-difluoromethane, BTM, and the latest medias like FM200, heptafluoropropane, Novak 1230, etc. Because the halogen based medias are replaced by other medias due to the ozone depletion potential of those medias. Then we learned about other medias like sand, and also in the next chapter we learned about dry chemical powder. So these are the main medias which we learned. And one of the main things which we learned is classification of fire. Depending upon what is burning, fire is classified into class A, class B, class C, and D as per the Indian standards. And international standards like NFPA and all, we have class K. And what method is to be adopted for each class. So all these we discussed in this chapter. And in the third chapter, we have discussed mainly about the portable fire extinguishers, which are the fire extinguishing appliances used in the incipient or the starting stage of firefighting. And mainly we discussed about two types of extinguishers. One is cartridge operated, second is stored pressure. So in cartridge operated, we have carbon dioxide cartridges or small cylinders fitted inside extinguishers. And the extinguishers may have medias like water, foam, dry chemical powder, etc. And in the stored pressure extinguishers, the extinguishers are pressurized with nitrogen. And that also are available depending upon the media like water, foam, mechanical foam, dry chemical powder, etc. And we mainly discussed about the operation of these extinguishers. And apart from these extinguishers, we have carbon dioxide cylinder extinguishers, where carbon dioxide is stored in a liquid form under pressure, which can be opened to release the carbon dioxide gas. We have discussed about various maintenances, also maintenance to be carried out on the extinguisher in that chapter. So in the next chapter, we have discussed about certain hydraulic formulas, because water is the most common extinguishing media which we use. So to calculate velocity of water, to calculate the discharge rate of water, to calculate the frictional loss, nozzle discharge, and jet reaction in the nozzle. So formulas are given there. With those formulas, we can calculate these, because while practical firefighting, all these factors are very important, because the right amount of water at required pressure has to be applied to extinguish a fire, which is very important as far as fire extinguishment with water is concerned. Then we also discussed about the pressure of water and factors like atmospheric pressure, which is very important as far as pumping is concerned. Water hammer, which is a common problem which we face on houses, which causes hose to burst. There is a sudden increase of pressure due to the sudden closing of valve, which is generally referred as water hammer. The next unit we discussed about various pumps and primers. Pumps are machines which impart energy to fluids, and we have discussed about positive displacement pumps, and there we had reciprocating and rotary positive displacement pumps. In the reciprocating rotary positive displacement pumps, we learned about single acting force pump, double acting force pump, lift pump, bucket and plunger pump. And in the rotary positive displacement pump, we learned about a gear pump. And the negative displacement pump is your centrifugal pump, single stage, multi stage centrifugal pumps. And apart from these pumps, we also discussed about a ejector pump, which works on Venturi principle. Then the second part of the chapter was primers. The purpose of the primers are to exhaust the air from the suction side of the pump, mainly used with the negative displacement pumps. The various types of primers we learned was about reciprocating primer, exhaust gas ejector primer, and a water ring primer. So this is what we learned in that chapter called pumps and primers. The next chapter was about hose and hose fittings. Hoses can be classified into three categories. One is your suction hose, which can be either fully embedded or partially embedded, available in lengths of 2.5 to 3 meter pieces, fitted with threaded couplings, available with fire tenders and trailer pumps, etc. Then your delivery hose, which can be either lined delivery hose, which is referred as non-percolating, or unlined delivery hose, which is referred as percolating delivery hoses. And they are fitted with couplings which can be removed, instantaneous couplings, we call it instantaneous couplings. And small hoses, called first aid hose reel or hose reel hose, having a diameter of 19 mm to 32 mm, fitted on drums. So these are the various hoses which we learned. And as far as fittings are concerned, threaded couplings, instantaneous couplings, branches, controllable, non-controllable branches, standard branch, Gilmat 750, which is a branch explained in this book. Then other fittings like breechings, standpipes, hose ramps. So just know the purpose of these fittings and what for it is used. And also we discussed about the various maintenance to be carried out on fire hoses and how these hoses are to be stored and how it is to be rolled. Various methods like roll, Dutch roll, figure of eight. This was a common chapter, and the next chapter we learned was about form and form making. Because unlike the other firefighting medias, form is a media which is generated at the scene of fire. So foam is basically frothy solution made out of water and foam concentrate. And the two processes are mixing water with foam concentrate is the first process, and the second process is adding air to the foam solution formed from the water and concentrate. And as per the expansion, how foam is classified: low expansion, where you have an expansion ratio of less than 1 is to 20; medium expansion, where you have an expansion ratio from 1 is to 20 to 200; and high expansion above that. Various types of concentrates: protein based concentrate, synthetic based concentrate. The common concentrate, synthetic based concentrate which we use is AFFF, aqueous film forming foam concentrate. Then equipments, low expansion form equipments like LX FMB form making branch, LX form making generator, LX monitors. Medium expansion FMB, expansion form pourer, high expansion generators, induction equipments like inline inductor. So these are the equipments which we found, learned in that chapter. So know the purpose of these equipments and various terms like concentration, expansion, etc. as regard to form making is concerned. So the next chapter was about fire protective clothing and breathing apparatus. See, fireman uses mainly three type of fire protective clothing. One is your approach suit when you want to approach near a fire, proximity suit when you want to go very near to the fire, and entry suit which allows the fireman to go into a fire for a limited period of time. And how these suits are made, the material, only Gentex aluminized fabrics. And about breathing apparatus, the various types of breathing apparatus like CABA or compressed air or SCABA, SCUBA, etc. were compressed air breathing apparatus. ELSA, emergency life support apparatus, which has got a limited amount of compressed air so that in case of an emergency you can use and evacuate. Then forced breathing apparatus, when you want to work for a prolonged time, air is supplied either from a cylinder or forced into the area. And the main equipment, which is your CABA or SCABA, or when you want to go underwater, we use SCUBA. So these can be either closed circuit or open circuit. In the closed circuit, the air which we breathe out is recirculated by enriching it with oxygen. Whereas in the open circuit, we have canisters or cylinders containing compressed air. This is used for breathing. and find out the capacity, etc. Formulas, all we learned in that chapter. Various parts of a breathing apparatus, which I think they'll be showing you in the practical ground. And in that, we also learned about how signal can be given by the lifeline, which is tied around the person who goes into the area, so that the attender can give a signal using the lifeline. How one pull means what, two pulls, continuous pull, etc. The next chapter we learned was about the fundamentals of electrical and electronics, and we learned what electricity is, the flow of electrons, static and dynamic electricity. And static electricity is electricity which cannot be moved, and dynamic electricity, the electricity which can be moved through conductors. And terms like current, which is the charge per second, voltage, the electromotive force which moves, resistance, the opposition to the flow of current, the power, the rate of energy that is used. Then various terms like conductor, insulator, semiconductors, conductor which conducts electricity, say insulator which does not conduct electricity, and semiconductor is conducts electricity in a controlled manner. Effect of current like chemical effect, heating effect, magnetic effect, Ohm's law. It's very important law as far as the basic electricity is concerned, because to find out the voltage, the current is multiplied by the resistance. And the fundamentals like AC and DC. AC is a current which changes its direction with respect to time. That is, every 180 degrees the direction of the current is changed. Whereas DC current does not change its direction with respect to time. Generation of electricity by electromagnetic induction in a generator. How when a coil is placed in between a magnet, when it is rotated, it cuts the flux, and a EMF is induced in that. Basic other terms like conductors, safety devices like fuses, circuit breakers. What is a circuit? Primary and secondary cells. Primary cell is your dry cell, and secondary cell is your accumulator, you can say, lead acid battery. And we have discussed about various precautions to be observed while working on electricity, which is very important. Like do not stand on rubberized material insulator while working, wear proper safety equipments, and lockout tagout system. That is, while working on electricity, make sure the supply is switched off, and first aid to be provided to the a person who has sustained electrocution. Any, as far as first aid is concerned, you'll learn it in your DFS 1. Then about electronics, we learned about the passive components and active components. What are the three passive components which we learned? One is resistor, second is capacitor, third is your resistor, capacitor, and third is your inductor. So these are the three passive components which we learned, and how these works, and what is the unit of resistance, symbol. These are all very important as far as symbol, because when you refer electronic circuits, only symbols will be shown. The unit of resistance is ohm, unit of capacitance is farad, and unit of inductance is Henry. Then we learned about the active components like the diode and transistor. and the semiconductor theory, what is a PN junction. So all these things we have discussed in that chapter. And when we work on electronics circuits in fire alarm system, detection system, these components are mainly fitted in those. And the next two chapters, one was small gears and hand tools and power tools. The gears used by firemen, like a fireman axe, sealing hook, apart from various equipments used for rescue, powered equipments like flame cutters, lights, floodlights, hand tools like common hand tools like hammer, vise, chisel, etc. So you should know the purpose for this, why for the tool and how they are classified. Normally in your examinations, a lot of questions are asked from these tools. And the last chapter we learned was about ropes, various types of ropes. That is your normal natural ropes like coir, sisal, manila ropes, etc. Then synthetic ropes, steel wire ropes, and what care should be taken to ropes, what checks should be carried out, and also discussed about various knots, hitches, and bends. So this is what we covered in this book. Mainly, it is the basic book of fire science. I hope I've been able to give you a basic idea on fire through this book. So if you have got any doubts on these chapters, it will be again repeated to you through your faculties. So with this, the revision of this book is over. Now Monday onwards, the classes will not be there. Regular classes will not be there in YouTube channel. That is, your live classes won't be there. We may upload some videos on various subjects which you can refer. And these classes, though these three books, that is DFS 6, DFS 7, and DFS 8, the classes which are conducted will be available in the channel. So those old students who are at the stage of completion, so that will be these classes can be useful to them. So as far as practical is concerned, it will be intimated to you. Now online practical lectures are being conducted through various other channels. You can contact your faculties about the practical training. So thank you very much. Okay, have a nice day. So hopefully this may be the last time we meet in person through live classes. Okay, so thank you for your support, and thank you very much.